All right, welcome back. So today we're going to go over Amazon Polly. But before we get started, hit the like button, subscribe, and share this with anyone you know who's taking the AWS Machine Learning Associate exam. So, Polly, bringing text to life with natural speech. In the digital communication landscape, the ability to transform written content into natural sounding speech opens new possibilities for accessibility, engagement, and user experience. Excuse me. Amazon Polly serves as the bridge between text and voice, using advanced deep learning to create lifelike speech that makes applications more inclusive and interactive. As the complementary opposite of Amazon Transcribe, Polly completes the speech processing cycle by converting your carefully crafted text into compelling audio experiences. So, the evolution. All right. So, Amazon Polly represents a significant advantage and advancement in text to speech technology. Moving far beyond the robotic voices of earlier systems, this service offers multiple voice engines, each representing different levels of sophistication and naturalness. The standard engine provides basic speech synthesis suitable for simple applications. The neural engine leverages deep learning to deliver more human like prosody and inflection. Long form engines optimize for extended content like audiobooks and articles, while generative engines use modern AI to create expressive, adaptive speech that responds to context and emotion. This progression from mechanical to natural speech synthesis reflects the broader evolution of AI technology, where machine learning models trained on vast amounts of human speech data can now replicate the subtle nuances that make communication feel authentic and engaging. So, the power of Poly extends beyond simple text reading through speech synthesis markup language, or SSML. This provides granular control over how your text is spoken. SSML transforms static text into dynamic, expressive speech by embedding instructions that guide pronunciation, pacing, and emotional tone. Common SSML applications include inserting natural pauses with a break time tag and emphasize important words using an emphasis tag. And it adjusts speaking speed for different audiences and provides pronunciation hints for proper nouns or technical terms. This markup capability enables you to craft precisely the audio experience you want users to hear, rather than accepting whatever the default text-to-speech output provides. Lexicons complement SSML by providing pronunciation dictionaries that map abbreviations and acronyms to their intended spoken forms. Instead of hearing AWS pronounced as individual letters, you can have Polly say Amazon Web Services automatically. This feature proves invaluable for brand consistency and technical accuracy in specialized content. Speech marks adds another dimension by providing precise timing information for each word and sentence in generated audio. This capability enables advanced applications like lip syncing for avatars, real time text highlighting as words are spoken, or synchronized visual effects that match the audio output. So, what we're going to do is get a little hands on, what do you call it? Hands on touch in the cloud. We don't have this bookmark, so let's go here, Amazon Polly. So the most effective way to do this is to get our hands on. So we're in the Polly hamburger menu right here. You have text to speech. All right. So let's go back a little bit. Okay. So click that hamburger menu, click text to speech. All right. So you have the different types, the generative, the long form, the neural, the standard. All right. Let's go to generative. You have the languages, English, the voice type, Ruth, Joanna, etc. We're going to stick with Ruth. Okay. So let's see. I hope this plays.
Hi, I'm Ruth. I can read any text for you. Test it out.
And you should have heard that. All right. All right, let's try this. Let's try this.
Hi, I'm Ruth. I can read any text for you. I just read, Hi, I'm Ruth. I can read any text for you. Did you hear that?
Okay. So you also have additional features here. speech file formats, sampling rates, for your audio quality, custom pronunciations. This is where you get that lexicon from your uploaded dictionaries. You can restore the default text, clear the text, etc. Let's just restore that default text. All right. You can also save this to S3 or download your finished file. And you can tag, we could try the tags in here. Oh, let me use, well, I don't want to do that. That's a little much. That would be in lexicons, I believe, where you can add the pronunciations, right? Choose a lexicon file, and then from there, you'd be able to go forward. Okay. So synthesis, reflect all your speech is saved to. Okay, so you can create a task to save this all in your S3 bucket. Okay, so at this point, you can export and integrate down, meaning you can download your audio into MP3 or .ogg. You can explore the advanced settings that you just did. You can see some integration options like the SDK when you talk about the lexicon and everything. All right. Okay, so we got that. Costs. Okay. So Poly operates on a transparent pay-per-use model based on character count and engine sophistication. Standard engines cost about $4 per million characters, while neural engines cost $16 per million characters due to their advanced processing requirements. Long-form engines command premium pricing at around $100 per million characters, reflecting their optimization for extended content. This pricing structure enables cost-effective experimentation for small projects while scaling economically for enterprise applications. The character-based billing means you pay only for actual speech synthesis, not for infrastructure or idle time. Okay. So there's strategic ways you could do this across industries. AWS has a number of ways that you can see this, right? In vehicle experiments, when your car is talking to you, gamified diabetes. So you're giving health information to help you live, sales concierges, right? Transformation of disputes in banking. So customer service, right? So Poly enables applications that were previously impractical or expensive to implement. Voice-enabled applications can now provide natural speech feedback without requiring human voice actors or complex audio production workflows. Content accessibility initiatives can automatically convert written materials into audio formats for visually impaired users or learning style preferences. And media localization becomes scalable when you can generate voiceovers in multiple languages and accents without hiring international voice talent. Educational platforms can create dynamic narration that adapts to content updates without re-recording entire courses. Customer service applications integrate Poly with services like Amazon Lex for conversational interfaces or Amazon Connect for call center automation, creating seamless voice experiences that feel natural rather than robotic. Okay, so how do you integrate this within the AWS ecosystem? So Poly integrates naturally with other AWS services to create a comprehensive voice-enabled architecture. S3 will store the generated audio files. CloudFront can deliver them globally with low latency, and Lambda can enable serverless speech synthesis triggered by events or user actions. Amazon API Gateway provides RESTful interfaces for real-time text-to-speech conversion. The service connects with Amazon Recognition to create accessibility solutions that read text from images aloud, combines with Amazon Translate for multilingual speech synthesis, and works with Amazon Comprehend to generate audio summaries of text analysis results. You can also do programmatic implementations, which is why we're here. Okay. So within this, beyond the console, Poly provides a robust programmatic interface through SDKs, CLI tools, RESTful APIs. And so a simple Python implementation can use Boto 3 to make a straightforward integration. We'll see this here, where you can get the lexicon, right? And so this code will get credentials stored in SDK for configuration, right? This is very simple, but it uses Poly, description, lexicon name, right? This is a programmatic way to enable automatic workflows or automatic and automated workflows and batch process content for dynamic speech generations based on user inputs, right? And you see on the left here, a couple of options: delete the lexicon, get the lexicon, list lexicon, right? And these are just the Python examples. And this goes on and on as to what you're able to do for user inputs or system events. So Poly can democratize high quality speech synthesis, make it accessible to developers and organizations without specialized audio production expertise. Whether you're building accessibility features, creating engaging user interfaces, or developing innovative voice enabled applications, Poly provides a foundation for transforming text into compelling audio experiences that feel natural and professional. That's all we have for this one. Before we go, hit the like button, subscribe, share this with anyone who's going to be taking the AWS Machine Learning Associate. The next one we're going to go into is Amazon Recognition. But until then, have a good day, and we'll talk soon.